Hello, students, and welcome to our algebra lesson and welcome to our new unit on systems of equations. We'll start, as always, with our do now, where today we will thoughtfully respond to a prompt about being an upstander. Our objective today will be to begin our unit on systems of equations, and we're specifically going to look at solving a systems of equations by graphing. Our essential questions are: what is a system of equations, and what does it mean to solve a system of equations? And then finally, our first systems of equations skill, so to speak, which is how can I solve a system of equations by graphing? That's our focus today. Our assignment will be to watch the video and complete the 2 pages, and make sure you include all related notes in your work. Okay, we're going to do a little note taking today. So we have our exit ticket question, where we will complete what a system of equations is. We'll talk about the algebraic solution and the graphical solution to a system of equations. We're working on turning on things in on time, so I want this lesson turned in by end of day today, and I'm not taking any late turn-ins, so you need to do your lessons as they are assigned. Your homework will be 5-1, solving systems of equations. And remember, to get full participation credit, we want the camera on, at least in the beginning during our discussion, and it'd be nice at the end just for a minute to say goodbye. Please respond when your name is called at the beginning, middle, and end of the period. Submit your completed lesson as assigned, and write to me with any questions. Remember, the marking period is nearly complete, so no more Unit 4 work is accepted after today. You have till midnight tonight. Now with Unit 5, I'm asking you to please stay current and do your best. Getting behind is a really bad place to be, and you don't help yourself by letting your work go. Now with regard to our do now, it says a bystander is someone who is aware that bullying is happening. So our context today is bullying. An upstander, which is a newer term, is someone who stands up for someone being bullied. So what can an upstander do to support a bullying victim? And, they could say something, but sometimes you won't feel safe saying anything. You could tell an adult, and you could, help be a friend and a support person to someone who's being bullied, and maybe help keep them out of situations where they are bullied. I'd like you to put your answer to that question here. We will get back to our exit ticket. And remember, we're going to work on our paper notes for our lesson. So our new topic is systems of equations. And specifically today, we're going to solve systems of equations by graphing. So first of all, what is a system of equations? Okay, so that's the first thing we need to understand. So a system of equations is 2 or more equations with the same variables. And as we move through this unit, you're going to see how we can use these in real life. So graphically, there's a point, x and y, where the 2 lines intersect. And algebraically, there is that point, x and y, that makes both equations true. So there are 3 types of solutions with our systems of equations. Most of them will be intersecting lines. So here's our intersecting point. This is the solution. Okay, we also have, okay, let's write that down, one solution, x, y. Okay, we also have parallel lines. You can end up with parallel lines. When we end up with parallel lines, there is no intersection, and therefore there is no solution. And then we have this unusual situation sometimes where our two solutions can end up being the same line. And when they end up being the same line, we say that there are infinite solutions to the problem. So when we solve a system of equations by graphing, these are the steps we take. Number one, we want to rewrite the equation in slope-intercept form. Sometimes it will be in slope-intercept form, but if it's not, you need to rewrite it. And that's both equations. Now, most of the systems of equations are two equations. As you get further in your math career, you will see more equations be part of a system of equations, but mostly in Algebra 1, we work with two equations. Okay, the second thing you will do is graph the line. Or lines. The third thing you will do is then identify the solution. Now, remember, as we look at this infinite solution, there might be more than one solution. So it could be solution or solutions. Okay, so remember, first, rewrite in slope-intercept form. Slope-intercept form is y equals mx plus b. Remember, that's plus or minus b. So these first two in number one, they are in slope-intercept form. So we just need to graph them. So y equals x minus 8. So the y-intercept is at negative 8, and we have a slope of 1. So we'll go down 1, 2, 3, 4, 5, 6, 7, 8. We have a slope of 1, so that's a rise of 1 and a run of 1. So this is our first line. And let's draw that line. Okay, and then the second equation, y equals negative 2x, or slope is negative 2 plus 1. So here's our y-intercept, and our slope is negative 2 over 1. So 2, 3, and let's graph that line. And it looks like those two lines intersect right at this point here. And that point here is 1, 2, 3, 1, 2, 3, 4, 5, 3, negative 5. So the solution to that particular system is 3, negative 5. That is the point where the two lines intersect. And number 2 is also in slope-intercept form. So let's graph the first line. Y equals 1/2 x plus 9. So we have a slope of 1/2, a y-intercept of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the slope of 1 over 2. 1. We can go down 1 and over 2 to do this one. We still have a positive slope. And the second equation, y equals negative x plus 6. So that's a y-intercept of 6. And a slope of negative 1. So I can see our intersection point right there. And this systems of equations intercepts right here at the point -2, +8. So that's solving a systems by graphing. So you have 6 more problems. So try those on your own and then come back to the video and let's see how you do. So for number 3, we have to put these in slope-intercept form. So the first one will end up being y equals 3x plus 8. And the second one will equal y equals x minus 2. Now we can graph the first one. So 2, 3, 4, 5, 6, 7, 8. The slope of 3. So we can go down 3 and over 1. So just down 3, 1, 2, 3 and over 1, down 3 and over 1, down 3 and over 1. So let's graph this line. Okay. I think I'm going to want to graph that again. Let me get my intersect of 8. And I think I'll use the line feature. Okay, here we go. And let's graph the second one. We have a y-intercept of -2 and a slope of 1. And I can actually see where this line is going to intercept now. So it looks like it intercepts at the point -5, 1, 2, 3, 4, 5, -7. And you can also graph these on Desmos as well, and you will be able to easily see your points. Okay, first thing we need to do is put this first equation into slope-intercept form. And when we do, we'll move x over, so we'll have 2y equals -x plus 4. Divide everything by 2, which gives us y equals -1/2 x plus 2. Now, look what we have here. So let's first graph this, y equals -1x plus 2. Here's our y-intercept, and we have slope of -1 over 2. Let's grab a line. And let's look at the second equation. What does it say? It says y equals -1/2 plus 2. So if we were to just, let's say, change the color and graph it, it's the same equation. So if it's the same equation, that means there's an infinite number of solutions, because every point on the first equation is a point on the second equation. So that's an example of an infinite number of solutions in a system of linear equations, which we solved by graphing. So let's look at number 5. So if we have y equals -7, -1, 2, 3, 4, 5, 6, 7. We know that's a horizontal line. So that's our y equals -7. And then we've got x plus 3y equals -15. And we'll put that in slope-intercept form. -1/3 x minus 5. So we come to -5, and we have a slope of -1/3. And let's put that line in. And we see that we have an intersection right here. Right here at the point 1, 2, 3, 4, 5, 6, -7. Okay, let's see, that first one is in slope-intercept form. The second one, -y equals -x plus 2. We divide everything by -1. And that would be y equals +x minus 2. So let's graph y equals +x minus 2. Which is pretty easy to graph. And let's graph, so we've graphed that. Now let's graph y equals x plus 5. That also has a slope of 1. And look at what happens when we graph this. We have parallel lines. They have the same slope. And if you look here, we have an invisible 1 here, and we have an invisible 1 here. So for both of those equations, the slope equals 1. They are parallel. They have the same slope, therefore there's no solution. So here's a no solution example. Last two problems. Let's start by putting that first equation in slope-intercept form. And when we do, let's see, we will have, I'll work over here, -5y equals -3x minus 35. Divide everything by -5. Which will give us y equals negative divided by negative is +3/5 x plus 7. -35 divided by 5 is +7. So this is the first equation. And the second equation, well, let's go ahead and graph the first equation. So we'll count up 7, that's our y-intercept, and our slope is 3/5. So we can go down 3 and over 5, 3, yes, up 3 and over 5. And we can change the color. And we'll do this second equation now. So that would be y equals negative 2x minus 6. So that would be y-intercept of negative 6, and we have slope of negative 2. And here's our intersection point right here. I'll try to do this by hand. And it looks like the point where they intersect is negative 5, positive 4. And then our last problem for the day, we have a vertical line, x equals negative 2. So if x equals negative 2, this is our line. And for the second equation, let's convert it to slope-intercept form. We have to do that first. Let's divide everything by negative 2 to give me y equals positive 3 over 2 x plus 9. So our y-intercept is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our slope is 3 over 2. So our rise is 3 over 2. 2, 3 over 2. Oops, over 2 right there. Let me double check that. Okay, 3 over 2, 1, 2, 3 over 2, 3 over 2. That looks a lot better. So, and we have our intersection point of negative 2, positive 6. So that's solving systems of equations by graphing. Let's go to our exit ticket. And let's review what we've done so far. A system of equations is two or more equations with the same variables. The algebraic solution to a system of equations is the point, remember that's xy, where the two lines intersect. The graphical solution to a system of equations, well, actually two lines, let me rephrase that, because I'd like to put that for graphical. Point where, okay, the algebraic solution to a system, the algebraic solution to a system of linear equations is the point xy, that makes both equations true. And the graphical solution to a system of equations is the point where they intersect. So it's the point xy where the two lines intersect. So remember, these two pages need to be turned in by end of day today. No late turn-ins for Unit 5. We're working on staying on top of our algebra and not getting behind. I know that you want to do well in algebra. I know that you're working hard, and I know that you will continue to practice. Don't forget your homework. It's just more graphing, and I think that with this practice, you'll be great. You've been terrific students, and you're going to be amazing.